So in the chapter ray optics, we studied some of the properties of light. That is reflection. What do you mean by refraction? So that is proved by considering. So light is having dual nature. So that we studied in the chapter dual nature of matter. So light is having two properties. One is particle nature and second one is wave nature. So in the chapter ray optics, so actually we studied some of the properties of the light like reflection, refraction, and some of the phenomena we are possible to prove by considering light as it is having a particle nature. But the properties of reflection and refraction is possible to prove by considering light is having wave nature also. But some of the phenomena, light, so light is having some other phenomena we already discussed in last class, that is, so light has dual nature. So that is first one, particle nature. Second one, wave nature. So by considering light as a particle, so we proved some of the phenomena or we discussed some of the properties of light like reflection and refraction. So I hope you remember this one. This one we already discussed. But the thing, so these reflection and refraction properties also can be possible to prove by considering light has a wave nature. But light has some other properties like interference, diffraction, and polarization. So these properties, these are also some of the properties of the light itself. And these properties like interference, diffraction, and polarization. So these properties are not possible to prove by considering light as a particle. But these properties are going to prove by considering light as a wave nature. Therefore, the difference between ray optics and wave optics is, so in both the chapters, we are going to study some of the phenomena or some of the theories related to light itself. But one thing you have to remember in the chapter ray optics, some properties or some phenomenon of light like reflection and refractions are proved by considering light as a particle. But whereas some other properties are there, so like interference, diffraction, and polarization, these properties are not possible to prove by considering light as a particle. But these are possible to prove or these are possible to study by considering light as a wave nature. Therefore, in the chapter wave optics, what we are going to study? So in this chapter also we are going to study some of the properties of light itself. So here, wave optics. So what is the meaning of wave optics? So already we discussed the meaning of ray optics. So in the chapter ray optics, it is the study of light and its energy of some of the phenomenon of some of the phenomenon of light like reflection and refractions are studied. So let us see what is the meaning of wave optics. So the meaning of the terminology, wave optics. So wave optics means it is one of the branch of physics. So in this what we are going to study is, it is the study of light, one of the branch of physics. In this, we are going to study about light nature itself. So it is the study of light and its properties. and its properties, but by using which nature? Wave theory of light. By using wave theory of light means by considering the property of light, it is having dual nature, but some of the properties like interference, diffraction, and polarizations can be studied by considering light as a wave nature. Why? Because so these are possible to prove by considering only light, by considering only light has a wave nature, but it is impossible to prove by considering light as a particle nature. Therefore, wave optics is one of the branch of physics. In this, we are going to study some of the properties of light interference, diffraction, and polarization. So, how we are going to define this one is study of light and its properties using wave theory of light is called wave optics. So that we are going to call wave optics. So, but in ray optics, there also we are going to study property of light like reflection and refraction by considering light as a particle nature. So light has dual nature. So in ray optics, we studied some of the phenomenon by considering light as a particle nature, but in wave optics, we are going to study some of the phenomenon or some of the properties of light by considering light as a wave nature. So this is the meaning of wave optics. And next, some of the introduction part related to wave optics we shall see. So here we discuss some of the phenomenon of light in ray optics also. So here the scientist described the, so the scientist, name of the scientist is Discretes. So he gave the corpuscular model of light. He gave the corpuscular model of light and he derived sense law. So this we are going to see further how we are going to derive this one by considering wave nature of light. So here the corpuscular model further developed by scientists. So this corpuscular model further developed means that is continued, further developed by the scientist Isaac Newton. So in the textbook, which book? Opticus. So in this textbook, the corpuscular model of light first studied by the scientist Discretes, and further that theory is further continued or studied by the scientist Isaac Newton in the book Opticus. So next point. So the corpuscular model, what it predicts is, so it predicts that if the ray of light, so when it travels from rarer medium to denser medium, so it bends towards the normal that we already studied. Then the speed of light would be greater in the second medium. So first medium is rarer medium and second medium is denser medium. So this phenomenon experimentally proved is wrong. It was shown experimentally by the scientist Fault. So next scientist, he identified this fault. The speed of light in denser medium is less than the rarer medium. He identified that one. So some of the phenomenon we studied, some scientists, so they identified some phenomenon and thus that was again rechecked by some scientists. So next in the year 1678, the scientist Christian Huygens, name of the scientist is Christian Huygens. So he put forward the wave theory of light. He put forward the wave theory of light. So this is one of the phenomena. So that is studied in the chapter wave optics. Next, another scientist, Maxwell, he studied electromagnetic wave of light. Electromagnetic wave theory of light. And Maxwell developed a set of equations describing law of electricity and magnetism. And using these equations, he derived wave equation from which he predicted the existence of the electromagnetic waves. And next, Maxwell said, light must be an electromagnetic wave and it is associated with the changing electric and magnetic field, so which results in the propagation of electromagnetic waves even in the vacuum. So this Maxwell's equation you are also going to study in the chapter 8th chapter. So here these are the some of the phenomena so that different scientists identified and they gave different theories and they identified different theories, and this is we are going to cover in introduction part. So what we discussed is first point. So here discrete he gave the corpuscular model of light and he derived Sen's law. And the corpuscular model further developed by another scientist, that is Isaac Newton, and he in the book Opticus. And next, the corpuscular model, and that is predicted. What it is predicted in the corpuscular model is if the light in the denser medium bends, then the speed of light would be greater in the second medium. That is given by in the corpuscular model. But it is wrong. That is identified by the another scientist fault. That what he identified is the speed of light in the denser medium is less than the rarer medium. So next in the year 1678, another scientist Christian Huygens, he put forward the wave theory of light. So in the year 1678, he put forward the wave theory of light. Next, another scientist Maxwell, he identified electromagnetic wave theory of light, and he said that in that light must be an electromagnetic wave and it is associated with charging electric and magnetic field. And he also found some of the Maxwell's equations related to electromagnetic and electric and magnetic fields, and he gave some of the equations, and those equations we are going to study in the chapter 8th chapter. So this is all about introduction part, and next we shall see what is the meaning of wavefront. So here the meaning of the wavefront is, it is defined as, we are going to call that one as surface of constant phase. So wavefront ante enan karitive, so that is, it is defined as surface of constant phase. Example idu kododadre, suppose if you throw the stone in the water, again akriti, A stone in a water alli you dip, suppose consider the river. In that river, if you put the stone, means what it happened, the water molecules it form a circular loop that form ಆಗ್ತವೆ. So that we are going to call wave front ಅಂತ ಕರಿತೀವಿ. So how it is formed means, when a stone, let us consider this is the stone you are dropping. So when a stone is dropped on the calm surface of water, again water molecules at the point of impact starts to vibrate. ಅಲ್ಲಿ ಹೋಗಿದ ತಕ್ಷಣ ಏನಾಗ್ತೈತೆ ನೀರೊಳಗ ಅವು ವೈಬ್ರೇಷನ್ ಆಗಕ್ಕೆ ಶುರು ಆಗ್ತೈತೆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. So these vibrations spread outwards on the surface of the water in the form of a circular ring. The diagram ಅಲ್ಲಿ ತೋರಿಸ್ದಂಗೆ ಏನಾಗ್ತೈತೆ, ಕಲ್ಲು ಹೋಗಿದ ತಕ್ಷಣ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇಂದ ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತೈತಿ. ನೀರಲ್ಲಿ ನೋಡಿರ್ಬೋದು ನೀವು. The vibration spread out and surface of water, it forms a circular ring as shown in this diagram. So all the particles on the circular ring are in the same state of vibration. ಇಲ್ಲಿ ನೋಡ್ರಿ ಬೇರೆ ಬೇರೆ ಲೂಪ್ ತೋರಿಸಿನಂದ್ರ they are all in the same state of vibration. ಅದರ ಮೀನಿಂಗ್ ಏನು, that is phase of all the particle is same ಅಂತ ಅರ್ಥ. So this is because all the particles in a ring are at the same distance from the source. Such a locus of particles in the medium or locus of point in case of light which oscillates in the same phase is called wavefront anta kariತೀವಿ. So wavefront meaning ಏನು, it is the surface of constant point. So when a stone is dropped in the water, again it forms a circular loop and the point they are in the same phase. In a loop formation ಆದರೂ ಕೂಡ all the point in the circular loop they are in the same state of vibration anta meaning. Therefore wavefront is defined as surface of constant phase, or you can define it is the locus of point of a constant phase. And the wavefront based on shapes, they are classified into 3 types. So wavefronts are classified based on the shape. They are classified into 3 types. Those are spherical wavefront, second one cylindrical wavefront, third one plane wavefront. So how these are going to form, let us see. So these are classified based on the shape. So how wavefront is going to happen and different types of wavefront, how they are going to form, I am going to show in the video. So the voice is audible now? Yes. So here as shown in the diagram, so if you put a stone in the water, so here it looks like if you put a stone in this water, what it happens? It forms the circular loop. ಇಲ್ಲಿ diagram ಅಲ್ಲಿ ನಿಮಗೆ ಕಾಣಿಸ್ತಿದೆ, ಇಲ್ಲಿ circular loop formation ಆಗಿತ್ತಲ್ಲ. So this we are going to call that one as wavefront ಅಂತ ಕರಿತೀವಿ. So wavefront ಅನ್ನ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು? So means that is the disturbance of the particles in the medium. So it is the surface of constant phase, or it is the locus of point of a constant phase anta kariತೀವಿ. So this is the meaning of wavefront. Stone na water pond olaga ಅಥವಾ water source olaga dip ಮಾಡಿದಾಗ it is going to, the water molecules are get disturbed and it forms a circular loop ಅನ್ನೋದನ್ನ ತೋರಿಸೈತಿ ಇಲ್ಲಿ. Next, different types of wavefront based on shape, how they are going to form another mele. We are classifying the wavefront into 3 types. Those are spherical wavefront, cylindrical wavefront and plane wavefront. So how they are going to form, let us see. So like this, different types of wavefronts are going to form. So here the meaning of wavefront is, so the wavefront at any instant is defined as locus of all the particles of the medium which are in the same state of vibration. So already we saw in the diagram, so the state of vibration, they are in the same phase. So same thing, based on shape, different shapes, the wavefronts are classified into three types, that is spherical, cylindrical and plane wavefront. So this is one of the type of wavefront it is going to form. So here, first type is that is spherical wavefront. So in the spherical wavefront, the wavefront of point source at infinite distance. But this is one of the example. Second type, this is cylindrical wavefront. Means, so this is the point of reference here. So here linear distance is shown here. So here it is the wavefront of linear source at finite distance it is. Same thing in case of linear wavefront. So this is one of the example for cylindrical wavefront. So in case of cylindrical wavefront, so the waves emitted by linear source of light is cylindrical wavefront. And here, these are different types of wavefront I shown here. So same thing we can possible to show. So different types of wavefront by drawing also we can possible to show that one. So let us see how that one. So different types of, so this is one of the example for, so this is the point of reference. So this is one of the spherical wavefront we are going to call. Means it is when the stone is dropped in a water pond or water source, it is going to form a circular loop. Therefore, it is shown like this. So this is spherical wavefront we are going to call spherical wavefront. So second one, how we are going to show this one? This is cylindrical shape is there. So here again it is going to form a loop here. So and again here also it is going to form circular loop, and here in between linear distance is there. So in the cylindrical wavefront, all the points are equidistant. Here if you observe these one, so all here also all the points are equidistant from the point of source. So in the cylindrical wavefront, so all the points are equidistant from the linear source. So this is the linear source we are going to call, and here this we are going to call cylindrical wavefront. Means based on different shape, we are going to give different names. Wavefront based on shape, we are classifying the wavefront into three types. And plane wavefront means how it is going to form is, plane wavefront is, it is going to form like this. So these are the light rays. So it is going to form like this. So what we are going to call this one? Plane wavefront. So in the plane wavefront, small portion of spherical or it may be cylindrical wavefront at a larger distance from the source will appear to be plane. So that is shown in diagram. So this is first diagram, spherical wavefront, and here this is based on shape. We are classifying the wavefront into three types. This is cylindrical wavefront, and this is third one. So that is plane wavefront. So in the spherical wavefront, all the points